In this video, we will discuss the relationship between arcs and chords. A chord is a segment with endpoints on a circle. If a chord is not the diameter, so if it doesn't go through the center, then we can say its endpoints divide the circle into a major arc and a minor arc. Remember from last time, the major arc is the big one, and then the minor arc is the small one. So major arc would be, we're looking at chord FG, this part, and if we're looking at chord FG, the minor arc would be this part. So in the same circle or in congruent circles, so if it's the same circle or if they're equal to each other, the two minor arcs are congruent if and only if their corresponding chords are congruent. So the arcs, so FG, if we look at FG and JH, those are going to be equal if the corresponding chords, so these parts, are equal. And it goes both ways. If the chords are equal, then we can say the arcs are equal. So let's take a look at how to prove that. So we have circle P. We know that QR, the arc QR, is congruent to the arc ST. And then we want to prove that the chord length, QR, we want to prove that QR equals ST. So we can do this by starting with QR and ST are equal. That's given. That's our given. If arcs are equal or congruent, the corresponding central angles are also going to be congruent. So we could say QPR, this angle here, equals SPT, equals this one. And then since all radii are congruent, we can say this equals this, equals this, equals this, because these are all radii of the circle. So then we have side, angle, side, side, angle, side. So then we can say the two triangles are congruent to each other by side, angle, side. And thus, since QR and ST are both sides, corresponding sides in congruent triangles, we can say corresponding parts of congruent triangles are congruent. So QR is equal to ST. Let's take a look at a couple examples here. So this first one, it says in the embroidery hoop, AB equals CD, so our chords are equal. So if these two are equal, right, this part equals this part, it tells us that AB, the arc length, is 60. Find CD. So we want to find this part here. So if our chords are equal to each other, if chords are equal or congruent in same circle, so we're in the same circle here, our chords are congruent, then arc lengths are congruent. So then if they're congruent, our CD, measure of CD, equals 60 degrees also. Well, let's look at one more example. In the figures, circle J and circle K are congruent to each other, and it tells us that arc MN is congruent to arc PQ. So we want to find P, the length of the chord PQ. So if our arcs are equal in congruent circles, so it's either if they're equal and congruent or in the same circle, then we know that the corresponding chords are going to be equal. So we know MN, the chord MN, equals the chord PQ. So then 2x plus 1, we'll substitute in the value for MN and PQ. 2x plus 1 equals 3x minus 7. Now let's simplify. Let's do minus 2x to get rid of 2x on this side. We get 1 equals x minus 7. Add 7 to both sides. We get 8 equals x. Now that we have 8 equals x, we can plug in, substitute our 8 in where we see an x, and we want to find the value of PQ. So it doesn't, they're both going to be equal, but let's just plug it into PQ. So PQ equals 3 times x. So instead of x, we'll write an 8 minus 7. So that gives us 24. PQ equals 24 minus 7, which is 17. And if we looked at this one just to double check our answer, 2 times 8 plus 1, so 16 plus 1 equals 17 also. And we said that they're equal to each other, so that checks out.